Hello, welcome back. This is AG3, Chapter 8, Section 5. We're getting close to the end. We're looking at proving similarity using SSS and SAS. So we'll be looking at both of those today. This is side, 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 and this is side, angle, side. Okay. Our essential question, what happened to the EQ? What are two ways to use corresponding sides of two triangles to determine that the triangles are similar? So our first theorem states that side, side, side will give us similarity. It's our theorem. If the corresponding side lengths of two triangles are proportional, then the triangles are similar. So we have ABC and RST. So if AB over RS equals the same thing as BC over ST, and that equals CA over TR, and if they all give you the same proportion, ratio, or fraction, then we can say that triangle ABC is similar to RST. So let's look at an example. This is example 1. I don't know why I got cut off on the top, but we're running out of time, so let's move. So is either DEF or triangle GHJ similar to triangle ABC? So how are we going to look at this? So here's ABC. This is the one we're starting with, and we want to see if either of these are similar. So what we're going to do is we're going to set up ratios, and notice it has 8 is our shortest side, 16th is our longest, and 12 is our middle. Well, we're going to look for the shortest, longest, and middle for each of these, and we're going to set up a ratio. So our shortest side's 8. So we're going to put 8 over 6. AB over DE. We also could look at the lettering up here. Remember I told you before, the lettering counts. So AB over DE. So next would be BC over EF. BC over EF, that's over here, that's our middle sides. And then our longest side is CA over FD, which is 16 over 12. Now if we settle these up and reduce them, we get 4 over 3 for all of them. And since all these fractions are the same, these are similar, and so we can say all the ratios are equal, so triangle ABC is similar to triangle DEF. So we're going to do the same thing for the other one over here. We're going to set up our shortest side over our shortest side, 8 over 8. Our longest side over our longest side, 16 over 16. And then our middle, our 12 over 10. Now 8 over 8 gives us 1. 16 over 16 gives us 1. But 12 over 10 gives us 6 over 5. And that all three of these are not the same, so therefore all the ratios are not equal, so triangle ABC and triangle GHJ are not similar. So another example on how to use SSS, you'll be using some algebra. So we want to find the value of x that makes triangle ABC similar to triangle DEF. So we have ABC, AB over DE, so we're going to get 4 over 12. And we want to set that equal to this one, so it'll be BC over EF, which will give us x minus 1 over 18. And so once we set this up, we can do our butterfly. And the way we do that is we go 4 times 18, and then we go 12 times x minus 1 in parentheses. 4 times 18 gives us 72. The 12 gets distributed to everything in here. So we're going to get 12x minus 12. And then we solve, the way that we solve this is we add 12 to both sides. I'm going to write it over here so we can see it a little bit better. We get 72 equals 12x minus 12. We're going to add my wall of equality and then add 12 to both sides. That goes away. We get 84 over here equals 12x. Now we divide both sides by 12, and that gives us 7 equals x. And that's going to be the value for x that makes both of these triangles similar. A little bit of algebra. I know it's new ideas. We're going to try our best. We're going to try with our butterfly. We have one other way of looking at this. and that is the side angle side theorem. If an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides, including these angles, are proportional, then the triangles are similar. So we have X and M are congruent by the one line in there, and so we want to look at these sides that hold the angle, and we want to see if they set up a ratio. So we're going to set up ZX, and that's the same as PM, and then we're going to set up XY, and that's going to be over MN. And if we do these fractions and they come out to be the same fraction or number, then we can say triangle XYZ is similar to triangle MNP. So let's look at an example, and we're going to do this one together. We have triangle SRT and C similar to triangle P and Q. So we know that both of these right here are 90. So we want to look at this side here over 18 and 28 over 21. So R and N are congruent, so that's done. We have our angle. We want to look at the sides now. So SR is 24 over 18, which is PN. And then we want to look at RT, which is 28 over 21. We want to reduce these. We divide the top and bottom by 6. By 6, we get 4 over 3. We want to reduce this. We're going to divide top and bottom by 7. And we get 4 over 3. And because these two are the same, and we have the 90 degrees, we can say triangle RST is similar to triangle NPQ by side, angle, side. Okay, so for your assignment, I copied it out of the book, although number 1 says question 3, and number 2 says question 4. You should be able to follow along. Give it a go. Let me know if you need any help.